Hi guys, it's Mr. Brian here. In this video, I'm partnering with Edukaji to guide you on the SPM 2024 physics paper. The paper we'll discuss today will be paper 1, which is your 40 objective questions. Right? Without further ado, we'll get started. Okay, so it's your 1 hour, 15-minute paper, yeah? Just 40 questions, objective. Let's start with question 1 straight. A long jump athlete of mass 60 kg makes a jump in a long jump competition. He hits the sand at a speed of 10 meter per second and stops after 0.6 seconds. Which of the following quantities are correct? So you got base and derived. Base is, by the way, you need to know you only have 7 base quantities, huh? And you must know all the 7, like mass, time, length, temperature, current, luminous intensity, which represents brightness, as well as one more amount of substance, which is measured in moles. So that one you all use a lot in chemistry. Must know all the 7. Okay, so speed is not, mass, okay, but time is not the derived quantity. So base quantity must be the 7 most basic quantities. They cannot be derived from anything else. Okay, answer is C. To prove to you that mass and time you cannot derive from anything else. It's the most basic. That's why we call it base. But speed is called distance over time, right? It's length over time. So you can derive it from something else. This one is not. So answer is C. Question 2. Which of the following situation involves impulsive force? Okay, let's go through. Passengers are thrown backwards when a stationary bus moves forward suddenly. Guys, this is called inertia. When a bus is stationary and then suddenly the bus moves, your body wants to maintain the original position at rest. That's called inertia. But B, the driver hits an airbag that is inflated during a collision. That sounds like impulsive force to me. Why? Because airbag is soft. Airbag is trying to increase impact time to reduce impulsive force. Okay, that's a classic example of impulsive force, but let's take a look at C and D. Raindrops fall from an umbrella when the wet umbrella is rotated and stopped immediately. This is again inertia. So imagine you spin the umbrella, the wet umbrella, you spin. So the raindrop will carry some inertia to keep on spinning. But then what happened when you suddenly stop? When you suddenly stop, the raindrop wants to keep spinning, but then the umbrella already stopped. That's why the raindrop will spin out of the umbrella, and that is how you remove the water. That is inertia. A coconut is falling from a coconut tree. That sounds like just normal free fall to me. Doesn't really have anything to do with impulsive force and impact and all that stuff. Answer is boy. Okay. Question 3. The equation shows the oscillation of a simple pendulum. You're not required to memorize this, so don't worry about this. Just need to know how to obtain the x and y axis from the graphs. And I think this is something you'll do in maths a lot also. Look at the options. Is t squared against L for all of it? T squared against L. And if I go and look at t squared and L, right, you will see that the 4 is a constant. 4 will never change. 4 will always be 4. Pi is also a constant. Pi is always just 3.142, right? You square it, it's still a constant. It does not change, a fixed number. The G value on Earth also will not change. It's 9.81. So all these are constants. They don't change. Which means, I always tell my students, if you see a simple formula like that, it looks scary, it looks very long, but it's actually quite simple. And if you see a y-axis and an x-axis both on top of a fraction, meaning t squared is on top of 1, t squared over 1 is on top of a fraction, L is also on top of a fraction. If both also is on top of a fraction, one on the left side, one on the right side of the equation, this is definitely directly proportional. If everything else multiplied to it or divided is just a constant. That's why we get a directly proportional shape. Answer C. Okay, answer C. The diagram shows, question 4, the diagram shows a ticker tape obtained from an experiment with 50 Hertz frequency. What is the final velocity of this motion? Well, final velocity normally is what we call as the V. The big question would be to ask ourselves, if I tell you direction of motion is like this, do we know whether the left side or the right side is the start position, right? And if the arrow is like this, it means that you are starting here, guys. And the end is here. Okay, the start and the final is one on the right and left. So a lot of people will mix it up. They will think that the start is the balik. Please take a look at the arrow. Okay, direction of motion, that means you're pulling the tape to the right side. The right side is the start. The right side will give you the initial velocity. Left side will give you the final velocity. So to find the final velocity, it'll be distance here, the gap here, divided by, you must know this number. For ticker tape, one tick is always equals to 0.02 seconds. So this is going to be 3 divided by 0.02, 150 cm per second. I purposely do cm because all my options are in cm. Okay, don't have to change to meters or else you need to do double work later. Okay, can? Okay, number 5. Diagram 2.1 shows a ball hitting a can. 2.2 shows the situation after the collision where the ball and the can move separately. Okay, this sounds like some kind of collision. To be specific, because they move separately, therefore I think this should be an elastic collision. Right, elastic collision. Then let's take a look at the question. Which of the following statements is correct? Okay, the total force before and after is equal. Before collision, after collision equals. I don't think so. The velocity before equals to after. Not necessarily. The total acceleration is equals. No. The total momentum before collision, after collision. Yes. This is the very classic way of describing the principle of conservation of momentum. Guys, what is the meaning of conserve? Conserve means equal, means I maintain it. That means that the momentum in the whole collision before and the whole collision after stays unchanged. Is conserved, is the same, is equals. Okay? So momentum same, but the speed doesn't need to be the same. Velocity need to be the same. No. Acceleration need to be the same. No. But the momentum is the same. That's why we get a equation like this, right, for principle of conservation of momentum, where we say, if I multiply the mass of this guy times the initial velocity of this guy plus the mass of this guy, initial velocity of this guy, this is the momentum, it would be equals to the mass of this guy times the final velocity of this guy plus mass of this guy and this. It will be equals. It is conserved. That's why we can form a equation like that also. Yeah. Okay. Question 6. Diagram 3 shows an athlete in a weightlifting event. Which of the following factors cause the barbell difficult to be lifted? Why is it difficult to be lifted? Lifting force makes it easier to lift. Yeah? There's no buoyant force here for sure. This is not a hot air balloon or anything. Impulsive force, not really, because there's no impact. Answer is C. This is testing you whether do you know the weight of the barbell means the gravitational force. Yeah, because the weight is constantly being downwards. This is the weight, gravitational force, which is why it's difficult to lift something heavy because there is weight. Yeah. Okay. Question 7. Which of the following statements is correct about free fall motion? The velocity of a free fall object is uniform. Wrong for sure. Guys, free fall means you usually start with a 0 and then it falls and it gets faster. Yeah, it gets faster and faster and faster and faster. So please don't say the velocity is going to be the same. The acceleration will be the same though. Yeah, the acceleration would be the same, no? Free fall object does not experience the action of force except of the gravitational force. That is correct. Free fall means we ignore everything else. Ignore air resistance, ignore friction, ignore everything else. We just focus on gravitational force. Okay. Objects of different mass will fall with different accelerations in vacuum. Nope, because in vacuum, it's free fall. In vacuum, the acceleration must be 9.81. Okay, so it will not be different mass, different acceleration. I like to say this in class, you drop an elephant and you drop a feather in vacuum, their acceleration is the same. A feather so light and an elephant so heavy, they will have the exact same acceleration in vacuum. Okay, number 4, object that falls freely experiences a gravitational acceleration. Yeah, that's true. Usually it's 9.81. So answer is 2 and 4. So that would be C. Okay, question 8. The diagram shows two satellites, Y and Z. They have the same mass. Moving around point X on Earth, the position of satellite Z is further than Y. Okay, Z is further than Y. Which of the following statements is correct? The gravitational force. Okay, so they are comparing all just the gravitational force. Okay, so we want to see who is bigger or smaller. I think X and Y has a bigger gravitational force compared to YZ. Why? Because if you are closer to the Earth, you are being pulled with more gravitational force. Make sense? Right? So we are looking at just the distance actually, because the mass is the same, right? And if we pull out the gravitational force formula, which you can find in your formula sheet, son. Okay, right now, this one is a constant, gravitational constant. Mass of Earth, constant. Mass of satellite, both also same. Okay, so the only thing changing here is between these two. Do you see F is on top? R squared is at the bottom. F and R squared is inversely proportional, meaning a smaller distance would give me a greater gravitational force. XY is greater than YZ. Answer is A, yeah? Not equals, must be greater, not smaller, not equals. Number 9, what will happen to the satellite when the satellite linear speed becomes less than the intended linear speed? Okay. It will fall and crash to the Earth. Yeah, maybe eventually it will fall and crash, but let's see if there's better answers. Fall into a lower orbit and spiral down to the Earth. That means it will fall down to a lower orbit and then it will slowly go and hit the Earth. Okay. C, fall into a lower orbit and continue to orbit the Earth. That means it will fall down and it will act like nothing happened and keep on going on. Okay. Last one, move in a straight line in space. That sounds like it will escape to outer space kind of thing. So I don't think A is correct. I don't think so it can continue to orbit. This is the part that is wrong. It won't just fall down and then continue like nothing happened and keep on going. No, definitely no. It would fall down and slowly hit the Earth. Slowly get closer to the Earth, spiral down to the Earth. And I feel the best answer is B. Okay, best answer is B. By the way, linear speed is this, right? Okay, what this formula is telling us is that if let's say I have a certain orbit, let's say this is the Earth. Please be reminded, any satellite, regardless of whatever mass, so this satellite could be 100 kg, this satellite could be 200 kg, this satellite could be 500 kg, it doesn't matter. If you want to be at that orbit, if you want to be at that height, at that orbital radius, you must be at a certain speed. Do you see that in this formula, there's no small letter m? No small letter, there's only big letter m, which is mass of Earth. Okay, that means mass of satellite doesn't affect this. Small letter m means mass of satellite. Mass of satellite does not affect the linear speed. This formula tries to tell us something very important. You want to be at a certain distance called r, no problem. You must be at a certain speed. And what happens if you are slower than the intended linear speed? You're supposed to be at that speed, but what if you are slower than that? You will start to fall down because Earth will pull you back. There is a strong gravitational force to pull you back. The only reason why you can keep on going round and round and round in circles is because you are fast enough, because you maintain the speed. So if you don't, you will fall down. Yeah, because Earth will pull you back. So that's how it works. Huh? Number 10, boiling water is poured into an iron cup. Which of the following statements is correct about when thermal equilibrium is reached? Water temperature decrease, temperature of iron cup decrease. No, iron cup should be hotter, but we are talking about thermal equilibrium, so the best answer I feel is temperature of iron cup and water will be the same. Thermal equilibrium, huh? No heat conduction. Got heat conduction still. Okay, there's still going to be heat transfer between the two things. Same temperature, thermal equilibrium, that one quite easy. Number 11, the diagram 5 shows water heater used in a bathroom. The water temperature changes rapidly when the temperature regulator is adjusted. Which of the following pairs of metal and specific heat capacities is the most suitable to be used as a heating element in a water heater? The keyword, this one, heating element. Okay, straight away, those of you who have done a lot of past years, you will know, I must choose nichrome. Because heating element needs to have something with a high resistivity and also a high resistance. This thing comes from this formula, which you can find in your formula sheet, which is in Form 5, Chapter 3. Okay, if I have a high resistivity, it makes sure that I will have a high resistance. And what does that mean? It means that in a metal, I make it so difficult for current to flow, resistance very high, that as a result, this piece of wire, this element, becomes really hot. It produces a lot of heat because very difficult for current to flow. So it becomes very, very hot. That's why I can heat up water. Okay. Then also at the same time, I think I want a low specific heat capacity because this wire needs to be a good conductor, need to conduct heat to the water, right? You want to heat up the water, right? So must be good conductor of heat. Must have a low C value. Okay, small specific capacity. Answer is C. Okay. So question 11 actually makes a little bit of a very popular concept from 5 chapter 3. This one must know. And then another opposite one that you must know is copper. These two very popular, nichrome and copper. Copper has one of the lowest resistivity, therefore have very low resistance. So if you don't want a heating element, usually you would want a copper wire. For example, let's say I want the wire to charge my phone, a phone charger, a connecting wire for phone charger. That one you don't want to produce heat, right now. Phone charger, I want it to just have current flow, low resistivity, low resistance. Okay. Number 12, this is a air humidifier, 36 volts, 290 watts, converts fragrance liquid into mist. Okay. Mist is produced after 3 minutes when the air humidifier containing 200 grams of fragrance liquid is used. What is the value of specific latent heat of fragrance liquid? Okay, so we have 36 volts, 290 watts. Let me just put down 36 volts. Huh? And then I have time and also mass. All these are from the question. and I want to find latent heat, which is L. So the moment you write down all this information, you realize immediately, according to our formula sheet, I definitely have to use this formula for latent heat, Q equals to mL. Okay, the mass I have. Latent heat I want to find. The Q, the heat, do you have or not? Don't have, right? And so you pandai-pandai lah, because you look in your formula sheet, you will see that there's another way to find heat. And based on this information, the other way to find heat is called PT, right? So how to find heat? I would multiply power and time together. So you see, I got P, I got T, I got M, I can find L already. That's why we will combine this together. PT equals to mL. You don't want to combine also can, you can find the heat first, right? But the Q is just going to be the PT. So I'm going to sub everything here, 290 watts. Be careful, guys. The time I will change to seconds. The mass, however, I'm going to leave it as grams. How come? Take a quick look at all the units. Joules divided by grams. Yeah, so whatever here, right, is in SI unit. I use watts, I use seconds, which means I'm going to get the SI unit for heat energy, which is joules. And then here, it is grams. So what happens is, end up, your latent heat is going to be joules divided by gram. Can I? In your calculator, you all can go and type like this lah. (261 joules per gram). Okay, that's how you do it. Question 13, the diagram 7 shows two balloons which have the same mass of gas in two different places. Same mass, okay. Which of the following statement is correct? Balloon in the room, balloon in the snow area. Immediately in my head, I'm thinking, you go to a snow area, it means your temperature decrease, right? And it looks like, according to this picture, the volume decreased. Okay, which of the following statement is correct? The higher the temperature, the higher the volume. Sounds correct to me. Temperature go up, volume go up. Or temperature go down, volume go down. Same, huh? I think answer is A, but let's check the rest. Higher temperature, lower volume. That's wrong. Higher pressure, higher volume of gas. Nothing to do with pressure in this question. And then last one, higher pressure, volume does not change. Volume clearly changes. So the best answer is A. Okay. If you don't know how to see, teacher, how to know volume never changed? Because the question never mentioned anything about pressure, right? Which means, what is the pressure pressing on the balloon? Atmospheric pressure. That means inside here is also the same pressure, you know? What is the pressure pressing on this balloon also? Same. It's still atmospheric pressure. We never change the pressure. And so the gas pressure inside also the same. The pressure is constant. Right? If question asks, what law is this? What gas law is this? This is Charles' law. Okay, this is Charles' law. I always tell my students how to remember this is to think this lah. I don't know if you all know about this, but I don't think so, you know, unless you're my student. But best thing Charles planted was green vegetables. Okay, so how this works, right? Normally I don't write the whole thing, right? I just write best thing Charles planted was green vegetables. And you only need to look for either temperature, pressure, or volume that is constant. And in this question, pressure is constant, which means it is Charles' law, just like that. Look for the guy who is constant. So if temperature constant or volume constant, then you know it's Boyle's law or Gay-Lussac's law. Okay, so you got Boyle's law, Charles' law, Gay-Lussac's law, and then temperature constant, pressure constant, volume constant. This one, temperature changes, volume changes, confirm it's Charles' law already. Okay, whatever way works for you. Okay, yeah. Number 14, In year 1940, the hanging bridge Tacoma Narrows in Washington, USA collapsed due to strong winds which caused the bridge to oscillate at a maximum amplitude. Which phenomenon is related to this resonance? You have a bridge, let's say. Okay, so what happened in 1940 was one day there was a very strong wind. Now, somehow this frequency of the wind is able to match the natural frequency of the bridge. To those of you who don't know what is natural frequency, it means that naturally, when the bridge swings up, it likes to swing at a certain frequency one. That's called natural frequency, just like a pendulum. If you just swing a pendulum, this is a shorter pendulum. Let's say you have a longer pendulum. Different pendulums also will naturally like to swing a certain way. Some pendulum like to swing faster. Some pendulum like to swing slower. The bridge also have its own frequency, natural frequency. So every time the wind blows, the bridge swings. Somehow the frequency, every time the wind blows, it blows at the way or like how the bridge likes to swing at the natural frequency of the bridge. So it gains some energy from the wind frequency to swing higher and higher and higher until it reaches a very high amplitude, maximum amplitude. That's called resonance, where you get energy from somewhere and you swing more and more and more vigorously. That's why the whole bridge eventually collapsed, because it swing too much. Yeah. Okay. Question 15. Diagram 8 shows two identical waves passing through the slits of a barrier of different size. Okay, so passing through a slit, that sounds like a diffraction phenomenon. Huh? Which of the following relationships is correct? As the size of the slit decreases, the energy decreases. That sounds correct. Because when you have a small slit size decrease, this wave will become weaker, has lower energy. And lower energy for diffraction means that it will curve more. When the wave curves more, it means that it diffracts more. Okay, curve more means diffracts more. So just based on the picture, right? If you see it curves a lot, that means straight away that is telling you energy is very weak. Diffraction is very significant. Okay, size of slit decrease, energy decrease. That sounds correct. Let's check the rest. As the size of slit increases, amplitude increases. Size of slit increase, amplitude increase. That actually also is correct. Because by the way, low energy means low amplitude. Amplitude refers to how high the wave will go. So it means that the wave will not go so high anymore because it has very little energy. Okay, high amplitude means will go up and down a lot. The distance from the middle is very high. Okay, the maximum displacement is very high. So it also sounds correct actually. But I think between A and B, A is a slightly better answer. How come? Because just based on this picture, it is a bit difficult to see amplitude. I can't really see how high the water is, but I can clearly see the energy is lower because of the way it curves in the first picture, right? And let's take a look at C and D. As the size of slit decreases, okay, the velocity of wave decreases. Oh, this is definitely wrong. When would velocity change? V only change during refraction. And if you don't know when does refraction happens when the depth of water changes or the medium changes. Like, for example, light travel from air, from going into air and going into a glass block is different speed or different medium, right? So only if those things changes, then it's refraction. So or else velocity will never change. As the size of slit increases, wavelength increases. No, wavelength doesn't change because the speed doesn't change, the frequency doesn't change. Answer is A. Best answer is A. Second best answer is B. Okay, if they didn't give A as the answer, I would choose B, actually. Right? But we sometimes objective is not about are all the other answers that I choose incorrect? Not really. Sometimes we just want to choose the best answer, the better answer. Okay, just based on this picture, I can see the energy because it curves, but I can't really see the amplitude as much. Yeah, that's why we choose A as the answer. Okay, number 16, diagram 9.1 and 9.2 shows interference wave pattern of wave when two coherent sources are located at a distance A. Which of the following is correct? Okay, they are talking about the relationship between A and X. So we are going to use the interference formula, given now this one. Okay, interference formula. Interference means overlapping of waves, by the way. Or sometimes we call it the superposition. And if I want to find relationship between A and X, I must move them to a different side. So what I like to do is, I like to multiply the D go up. I like to divide the A come down. Because X is like the responding variable to those of you who don't know. You can change the wavelength, the lambda. Will the D change or not? No. Will the A change or not? No. Only X will change. When you change the lambda, only X will change. When you change the D, everything else won't change except for X again. When you change the A, the distance between the gaps, the distance between the two sources, what will change? Only X will change. So X is like the responding variable, the one that responds to this experiment. And it looks like A at the bottom, X at the top. It gives an inversely proportional relationship. Yeah, one increase, one decrease. Answer is A. One up, one down. This one wrong, unchanged is wrong. Okay, number 17, which of the following applications is related to infrared ray? Infrared is like small pulse of heat that we use in a remote control for TV. This one is using UV. This one, we use a little bit of UV also. Sterilization, usually we use UV or gamma. So can. Okay, but infrared is B, popular, remote control for TV, aircon also. Number 18, diagram shows image of a coin filled with water. Which of the following is correct? This is refraction of light. How do I know so fast? Do you notice got two medium, air and water? When light travels to two different mediums, speed changes. Okay, so it looks like this question is testing you on comparing refractive index, speed of light, optical density, and wavelength, all that. Okay, so let's just see. In air, it is lower density, which means it is lower refractive index, the n value. Low dense means it is faster, greater speed or velocity. Okay, what else? They ask also for wavelength. Greater speed means greater wavelength as well. How come? Because from V equals to F lambda, when V increases, lambda increase. But the frequency stays unchanged because it's the same light source. If it's the same light source, the light never changed to a different kind of light, the frequency won't change. Okay, so V increase, lambda increases. So let's see, refractive index of air is higher. Nope, it's lower. Speed of light in air is higher. Okay, that sounds correct because we already say air is faster. Optical density of air is higher. No, we wrote that air is lower density. This is wrong. Wavelength of light in water is higher. No, in water is not higher. Water is lower. Air is higher. Answer is boy. Okay. Number 9. Diagram 11 shows the path of light of a fish in an aquarium when the incident angle is 50. Critical angle of water is 48. Which of the following light path is correct after it passed through point O? So light goes in. Okay. total internal reflection will occur, and so answer is going to be donkey. How do I know? Because it fulfilled two criteria. Number one, light is trying to go from a denser, oh, okay, denser to less dense medium. In this case, it is trying to go from water to air. Right? That's the first criteria. The second criteria, the incident angle is greater than the critical angle. The 50 degrees is bigger than the 48 degrees of critical angle. When you fulfill both, there's only two criteria for total internal reflection. It must happen in the dense medium, in the water, for example, denser water. And I must be bigger than C. Yeah, incident angle must be bigger than C. If that happens, total internal reflection happen, you're gonna see the fish on the other side at D like this. It will not come out to point B or point C. Okay, so that is donkey. Number 20, you have a convex lens. Focal length is this. Object distance is 16. What is the image distance? Okay, well, there is a formula that is thin lens. For thin lens like this, you can find in formula sheet given. For a convex lens, it is positive. For concave lens, it is a negative. F, the F will be negative one. Sometimes it can be plus or minus, but this is a plus, right? A positive value. You don't have to purposely write a positive lah. And the U value is always positive. Okay, U value will never be negative. The V value, if it's a real, if question say real image, okay, then the V will be a positive value. If question say a virtual image, then will be a negative V value. So the U here is 16, and I want to find the V. So what do we do here is a simple move over like this. I'm going to get 1 over 48. So V is just 48 cm. Yeah, everything is in cm. Final answer also in cm. Guys, you got a positive answer. So it means what? You got a real image. What if you get a negative answer? Virtual image. Simple as that. Okay. Question 21. Diagram 13 shows a luggage that is stationary on a travelator. Stationary, be really careful. It means what? Resultant force is 0. Okay, how come? Because acceleration is 0. Again, and then what is the frictional force exerted by the luggage on an inclined plane? Okay, that is the frictional force. Now, the thing that you need to do, first of all, is to go and split the forces onto a T-shape like this. Okay, a T-shape like this. How do I know that it must be a T-shape like this? Well, for an inclined plane, it's always going to follow the inclined plane, because if you go and label your forces, right, you also have something called a normal reaction right here. Okay, that's how the normal reaction looks like. It's not straight up. You want to draw a T-shape where the majority of the force is. Okay, teacher, what if I draw the T-shape like this? It means you're going to have the friction point like this. You're going to have your normal reaction point like this. And then the only thing point down is your weight. So a bit difficult, a bit susah on this one. And then you're going to have this 57 Newton pointing like this. It's not on top of the T-shape. So very difficult to go and change all these forces into a T-shape. So I say T-shape because the object is going to move up or down in this direction, right? So you want to make this W right now go on top of those T-shapes. And what I will do is to split this force into like this and like that. the first thing that you must make sure you know is 30 degrees is going to come here. If you don't know how it works, simple maths. You're looking at a triangle. That's 30. That's 90. This is 180 minus 90 and 30. You get 60. Okay, I'm going to rub this off because it's going to look very messy. So if that is 60, guys, this is a 90 degree. 90 minus 60 is 30. So in questions like this, we are always trying to move the angle from the question to where it is more useful, right? I want to try to move this 30 degree to right here, because if it's right here, it is more useful. Okay. Now, I'm going to split the force. This is what you learn in chapter 1.1.2 in Form 5, yeah? Cos means go closer. Sine means go away. That's how I teach my students. So watch. 50 Newton is going closer to 30 degree. That's why I'm going to write 50 closer to 30. I repeat, 50 Newton go closer to 30 degree to get to here. That's why this is called 50 cos 30. Okay, and 50 Newton is going away from the 30. Can you see now? The 50 Newton is going further. The 30 degrees is right here, but it's going further and further and further and further away from the 30. That's why we call this as 50 sine 30. 50 go away from 30 degrees. That's how I teach my students. And because it is stationary, it means that the force pointing this way must be equals to the force pointing this way. Right? And so by right, your frictional force is equals to the 50 sine 30. And then also you will notice there is a 57 newtons just sitting down there, right? So we by right also need to add all the forces in that direction. And so we're going to get 50 sine 30 as 25. And this is 57. And we get 82 Newton, which there's no answer. There's no answer here. Right? 82 is not part of the answer. So guys, actually there's a question error in this question. It's the only question error, only big question error in SPM 2024 for physics paper, right? But you will get an answer if you just did separately. You will find out that actually they just want this part, right? They accidentally forget to include this 57. Okay, so B would be the second best answer. But by right, the correct answer is supposed to be 82. Okay, correct answer is supposed to be 82. Yeah. Okay. Question 22. Which of the following diagram shows Hooke's law? Hooke's law has anything to do with elasticity. So answer is boy. Yeah. Anything to do with elasticity. Like spring, rubber band, bow and arrow. Yeah. The rocket is principle of conservation of momentum. Excavator is Pascal's. Right? And then a hot air balloon, this is Archimedes' principle. Yeah. Okay, 23. Which of the following features will increase the negative effect of inertia? So if let's say in a car, let's say you're sitting in a car, right? And you're moving in a car, and suddenly somebody press the brakes too hard. Your whole body will be thrown forward. Or sometimes your body might be thrown backward also, depending. Okay, depending on what type of inertia. But sometimes you're thrown forward, sometimes you're thrown backwards. Increased negative effect of inertia means you make it worse, Make the effect of inertia worse. Okay, if you use a seatbelt, it makes it better, right? Because if your body is thrown forward, the seatbelt will pull you back. So it makes it better, right? We want to make it worse. So this is not the right answer. Install automatic airbag. That makes it better because if my whole body thrown forward and hit the dashboard, I get an airbag. So it doesn't make it worse, this one. It makes it better. Dashboard made of hard material. The dashboard in front of your car there is made of a hard material. Does it make it worse if you have a big inertia? Yes, it makes it worse because if your whole body is thrown forward and then you hit the hard dashboard, your head is going to break. Yeah, so it's gonna be worse. Seats of driver and passengers are equipped with headrests. This is making it better because let's say if the car suddenly move forward, your whole body will be thrown back, and behind you there will be a headrest to hold your head so that your neck will not break. Can so the rest are to make it better. C is the one that makes it worse. Okay, C is the one that makes it worse. Okay, 24. Diagram 14 shows airflow of a wing of an aeroplane. Which of the following positions A, B, C, D experience highest pressure? Don't have to memorize who has highest pressure, who has lowest pressure, highest speed, lowest speed. Don't need to memorize. I always say to my students, the wing of an aeroplane, which is known as aerofoil shape, is to give you what kind of force? A lift force. Okay, as simple as that. If you want a lift force, the bottom part of this wing needs to have high pressure. So then only you can lift it up, because down there must be high pressure to lift up, and on top will be low pressure. You get it now? So you don't have to memorize, because to lift up, I need high pressure from the bottom to push up. So answer is A. Highest pressure, A. But highest pressure also means that down here has a lower speed. Bernoulli's principle. Okay, low pressure on top means that it has a higher speed here. So don't have to memorize, just know that it's lift force. You will know who has high or low pressure. You will then also know who has high or low speed. You work backwards. That would be easier. Yeah. Okay. 25. The diagram shows a ping pong ball pulled in the direction of a stream of water coming out rapidly from the filter funnel. So this is going against gravity. The ping pong ball very light and it doesn't fall down. It's being pulled up. Why? Because atmospheric pressure is constantly pressing it up. While the high flow of water here always creates a very low pressure region from the fast flowing water. Okay, so as a result, when V increase, pressure drops. This is Bernoulli's principle. That's why the ball will get sucked up like this. Okay. Okay, question 26. Diagram 16 shows a candle flame between two metal plates, P and Q. What happens to the size of the candle flame spread after the power supply is switched on? Okay, it will look like this. Okay, the positive, okay, so what happens is the flame, the heat from the flame is going to ionize the air around it, ionize the flame. Ionize meaning you are going to have positive ions and negative ions for the flame or for the air. You can say flame or air, doesn't matter. Positive ions definitely will be attracted to the negative plate. Negative attracted to the positive plate. That one's simple, right? But why is the positive one bigger in size? Is because positive ions are heavier, have greater mass and size, okay, as compared to negative ions. So that is the reason why the positive part of the flame looks bigger, negative part of the flame looks smaller, right? So at plate P, you're going to have a bigger flame. Q, you're going to have a smaller flame. Answers boy. Okay, can? Then next question, 27. The diagram shows the arrangement of dry cells connected in parallel. What happens to the effective internal resistance in the circuit? Well, if everyone here has an internal resistance of R, will I get a total internal resistance of 4R? That's not true. Why? Because in a parallel circuit, how do you add your resistance? It's 1 over R plus 1 over R plus 1 over R plus 1 over R, right? Not? Okay, and let's call this effective internal resistance as E. Okay, if you don't know what is E effective, Total. Effective means total. Yeah, the total if internal resistance, which is going to be 4 over R. How to find RE? We terbalik. Become RE over 1, and then here becomes R over 4, or a quarter of R, 1 over 4 of R, or 0.25 of R, right? Which means every battery by right have R, but now it becomes just a quarter of R only. The effective internal resistance total will decrease. Okay, the total will decrease. Okay, question 28. Diagram 18 shows an electric circuit. What is the internal resistance of the battery in this circuit? Okay, internal resistance meaning small letter R. This one, big letter R. This one, I. This one, e.m.f. Okay, and guys, very simple one. The moment you see the word internal resistance, I show you quickly the formula. The moment you see internal resistance, e.m.f, only have one formula. Take a look, all the other formula don't have e.m.f, don't have internal resistance, only this one, right? So confirm this already. E is equals to V plus IR. e.m.f is 4.5. V is... Okay, guys, we don't have the V. I got the I though. I want to find the small r, but I don't have the V. You know what? V you can always change to IR. Okay, maybe I write all together in the next step. Then we sub in a 4.5 equals to 0.5 multiplied by 8 plus 0.5 multiplied by small r, right? So you can do some simple maths here. 4.5 minus 4, you get 0.5, right? 0.5 over 0.5 is R. R is equals to 1. Answer C. Okay. Question 29. An electrical vehicle, EV, uses higher voltage battery between 300 to 800 volts compared to hybrid cars. So EV cars uses battery. That one we all know. It doesn't use petrol. And uses a higher voltage compared to hybrid cars. Hybrid meaning they are half EV, like half EV, half petrol cars. Huh? Which of the following statements is correct about the high battery voltage consumption? Consumption means, in BM it means penggunaan. Like how much you use literally, penggunaan. Okay, a high voltage can increase internal resistance. I don't think so. It doesn't mean because I use a high voltage, then it will make the resistance high. The resistance, the internal resistance depends on how you arrange the battery and the chemical that you use in the battery itself, the battery itself. Time for the battery to charge will become longer. Just because I use a high consumption, it doesn't mean I need to charge longer, right? So B, I don't think so is the right answer, but let's take a look at C. A large current must be used when charging the battery. Not really. Maybe yes, maybe no. It does not depend on... It doesn't mean that if a car use a lot of battery voltage, it means that when you charge it also you need a large current. Not necessarily. You might just need a small current, right? Because a lot of the time, high voltage means it might mean a small current a lot of the time. But B and C doesn't sound like the best answer. D, can increase the electric power to move car. That sounds like the best answer. What is the purpose of having a high voltage? It's because when I have a high voltage, I have more power. Apa maksud power? Power means how much energy in 1 second, how much output energy in 1 second to push the car forward. So a lot of people maybe might think B and C could be also the correct answer, but you read through everything and you ask yourself, what do you think is the best here? Yeah, high voltage doesn't necessarily means I need a lot of current to charge. I might need a lot of current. I might not need a lot of current. Depends also, right? Maybe I have a very high voltage to charge it. The current could be very small also. Yeah, so B and C is not the best. D is the best answer. The one that is most directly related to high battery consumption, high battery voltage consumption. Okay. Question 30. Electromagnetism. Diagram 19 shows an alternating current motor. Which of the following statements can increase the rotational force? So usually for a motor, we'll be thinking about how to increase the force, right? Either by increasing B or increasing current. Reduce the number of turns of coil. That's wrong, because if you reduce the number of turns of coil, so how many times you turn, the more number of times you turn, the stronger the magnetic field will be produced around it. Yeah, you have magnetic field produced around it. So if you have less turns, less magnetic field, if strength of magnetic field decrease, interaction becomes weaker, catapult field becomes weaker, force also becomes weaker. Okay, lower magnitude of current. Nope, I want more current. Reduce resistance of coil. Sounds correct, because it means that there'll be more current flow, stronger magnetic field, stronger interaction of magnetic fields, stronger catapult field. Reduce strength of magnetic field, decrease the B. Also wrong. I want to increase the B. Okay, but there's a small problem that I have with this picture actually. Because this picture is actually not an AC motor. This is a resistor. This is called a AC generator actually. Those of you who are sharp, you will know that this picture, they give the wrong picture. This is supposed to be an AC generator, not a motor. Okay, generator got no battery one. A motor needs a current, needs some battery usually to supply some voltage. In our syllabus also, we never learn alternating current motor, just so you know, right? We only learn an alternating current generator. Okay, but however, this is a small error only, but it doesn't affect your answer though. 31. The diagram shows an electric circuit. What is the ammeter reading when the switch is turned on? Guys, always remember, when question give you this is the voltage, not the e.m.f. Okay, this is the voltage, not the e.m.f. You always assume that it's the voltage. Unless they tell you that this is the e.m.f, okay, then only you take it as e.m.f. Or unless the question is telling you, okay, there's some internal resistance and all that, okay, then I will use e.m.f. Otherwise, just call it voltage, potential difference. Okay, what is the current? Ammeter reading means current. When the switch is turned on. When I connect this switch, something a lot of people don't know is that current will only flow through the switch. It does not flow through 2 ohm resistor and 4 ohm resistor. It only flows through the switch. Guys, this kind of things happen whenever you have a parallel circuit, and if the switch has resistance of almost 0, we treat it as 0. Now you think logically, common sense wise, if I am current, if I am the charge, would you want to pass through 2 ohm or 4 ohm or not? Knowing that the switch has no resistance almost. I don't think I'll pass through 2 ohm. I don't think I'll pass through 4 ohm. I think I'll pass through only the switch. And this is really what happens. Okay. And guys, this kind of concept is getting more and more popular starting last year and this year. So be really careful. When I flow through like this, no current at all pass through 2 ohm, 4 ohm. Yeah, it means it will just pass through. Current also is smart one. I will choose the easiest path, right? Unless if like I open the switch, then like normal it will pass through 2, it will pass through 4. Okay, who will have more current? 2 ohm will have more current because 2 ohm has lower resistance. 4 ohm will have less current because higher resistance, right? That kind of stuff. But right now we are just looking at the case where it is like this, okay? Which means your voltage is 12 Your total resistance is just the 6 ohms right here, and I want to find current. Based on V equals to based on V equals to IR, current is 12 divided by 6, which is 2 ampere. Okay, 2 ampere. That is donkey. Then question 32. What is the concept used by electric generator works to produce electricity? A generator is electromagnetic induction. Okay, this is for motor. Yeah, electromagnetic to induce electricity. 33. Which of the following is used to determine the direction of deflection of cathode rays caused by magnetic field in a Maltese cross tube? So in a cathode ray meaning electron flow, fast moving electrons, which also converts to some current flow. Because electrons flow one way, it also means that current flows the opposite. I hope you know that. And if you put a magnetic field there, you are giving it a B. Something I always tell my students, you're trying to find the direction of force. To deflect, meaning you need a force. The force will give you some deflection, some movement. If you are looking for for F, FBI, these 3 letters, guys, who is on the left? Which 3 letters is on the left? F is on the left. That's why you use left-hand rule. Okay, if in the question you're trying to find current, then you're using right-hand rule. So for example, like just now, question 32, you're trying to generate electricity, you're trying to induce current, you need to have some force or movement. You need to have some magnetic field. That is how you get current. If I try to find current, induce current, then I'm going to use, current is on the right, right? Not FBI. I is the one on the right side, meaning I use my right hand. Fleming's right-hand rule. So this one, the answer is Fleming's left-hand rule. Okay. 34. Which of the following shows the output signal displayed on the cathode ray? Okay. If you have 4 diodes, you see the current will flow through this one, and then it will go in here, and then it will come out like this, and then flow back. Okay, that's one. Then later when it flows again, it is going to flow from the opposite direction because this is an AC. It will flow through here. It will flow through these two, and then it's going to come back. Right? I went through very fast this thing, but the whole idea is that you will notice the 4 diodes are there to give you a full wave rectification. The capacitor is there to help you to smooth the current. It's called a current smoother or a smoothener. So what happens is you have an AC, which looks like this. Or maybe I draw 2. And then, after putting 4 diodes, you have a DC this time, which looks like this, full wave rectification. After adding a capacitor, your graph would now look like this. This is a smooth DC. Smooth as in, the graph that we are going to get would be like this. Okay, the black color one, the black color pen one is the smooth version. The purple color dotted lines is the ones that I just drew from here to, to show you how I draw the black pen one, right? But that is the smooth version. So my answer would be donkey. Okay, answer is donkey. 35. Diagram 22 shows a transistor circuit. Bulb L lights up brightly when the switch is turned on. Bulb L lights up brightly. Okay. Which of the following statements is correct? The base voltage exceeds the minimum voltage to turn on the transistor. Sounds correct. Collector current is controlled by the emitter. Sounds wrong, it's controlled by the base. Base resistance is small to limit the base current. Nope. Base resistance is usually bigger a bit to limit the base current. The collector current is lower than the base current. Nope, that's wrong. The collector current is always many times bigger than the base current. Okay, because it is trying to help you to amplify the current. So what happens here is, why do we say base voltage exceeds the minimum? You want to make sure that your base here has a high enough voltage, higher than every transistor has a minimum value. Let's say this transistor has a minimum value of 0.7 volts. You need to make sure that you are higher than 0.7 volts here. Then only it can turn it on, can activate the transistor. And then only the base current fully flows. Then only collector current will flow and the bulb will light up. Yeah, so that's how it works. And then 36, the diagram shows a curve of a radioactive decay. What is the activity after 8 days? Okay, you just take a look at the graph after 8 days is here. 1000, right? The activity is 1000. Okay, just like that. Yeah, just read from the graph. The following information is about a nuclear reaction. Okay, a nuclear reaction occurs in a nuclear reactor. This reaction needs to be controlled. All right. Which of the following statements describe the information? If they mention in a nuclear reactor, between nuclear fission and fusion, it has to be fission. This one you must know. Huh? And fission means split. Fusion means fuse, combined together. Fission means you have a very heavy nucleus like uranium and it will split. So the answer cannot be fusion for sure. Okay, so we read between A and D, see which is the better answer. The nuclear fission reaction produces two lighter nucleus and produce a large amount of energy. Sounds okay to me. D, the nuclear fission reaction occurs continuously and produce a large amount of energy. Now we read back, both also sounds correct, but we read back the question. The following information is about a nuclear reaction. This reaction needs to be controlled. Actually, question is asking you about this chain reaction. Needs to be controlled. If you don't control this chain reaction, it can have a chance of producing an atomic bomb, right? Because the atomic bomb, the physics behind atomic bombs, or the nuclear physics behind atomic bomb, and the physics behind the nuclear reaction in the reactor is the same. So what makes a bomb and what makes a nuclear reactor is you are able to control the chain reaction. Because uranium gets bombarded by neutrons, and then it splits into lighter nuclei. Can be 2, can be 3, can be more. But at the same time, it is also going to produce some neutrons again. And now these neutrons, they will go and they will go and bombard other uranium. And they're going to produce even more neutrons. And it's going to bombard even more. So it's going to get even more, even more, even more. Right? And if you don't control it, it becomes a bomb. So we have to control it. This question is a bit tricky. Yeah, A can be correct also, but D is a slightly better answer because they mentioned this. They're actually talking about chain reaction, not just the fission reaction. Okay, what is the function of a graphite core in a nuclear reactor? A graphite core is always to slow down. To absorb some neutrons, this one is the job of a control rod. Okay, graphite core is to slow down. And then, which of the following lights shows the energy of photons arranged in ascending order? Energy of photons must follow this one, or it must follow this formula. Either one. Huh? So depending on whether you want to use frequency or wavelength. Okay, ascending order meaning low to high frequency or high to low wavelength also can, because Wavelength and energy is inversely proportional. And I hope you know your rainbow colors. If you don't know, then very difficult. Red, orange, yellow, green, blue, indigo, violet. For my students, I like to tell them this is Roy gave birth in Vietnam. Roy gave birth in Vietnam. Yeah, sounds a bit funny, but a lot of them can remember it this way. And you have to know you are remembering for what? R stands for longest. Okay, longest wavelength meaning the lowest frequency one. Lowest frequency meaning the lowest energy one. So I want in ascending order meaning I want to start with red or orange or yellow, the one of the front ones. So this is red. Red won't be in the middle like this. Red and then green and then blue. Okay. Red, green, blue. Okay, that is in order. Or red, blue, green. Cannot. This one cannot terbalik. So answer C. Number 40. Which of the following statements explain the correct quantum theory? Intensity of radiation is high for high frequency waves. Nope. Photon energy is directly proportional to frequency. Yep. Because of this formula, frequency and energy directly proportional. Wave-particle duality is the same for all subatomic particles. Nope, that's not true. For electrons, it's usually the one that we can observe the wave-particle duality, but for protons, for neutrons, we cannot observe it. Yeah, and then D, the electromagnetic wave is transmitted by a black body is in a continuous form. Nope. For a black body, it is in a discrete form. That's why we call it a quantum of energy, a photon. It's released in photons. It's a quantum of light energy. If you're wondering why intensity is not higher, it's supposed to be low for low frequency waves, this is the start of chapter 7.1 where you have wavelength like this, and this is the intensity. And then remember the graph looks something like this. It goes up, and it doesn't continue to go up. It starts to fall down. Somewhere around the UV region, it starts to fall down. This is the part with low wavelength, high frequency. Notice when frequency is very high here, intensity is very low, not high. Okay, it's very low. That is all for your objectives for SPM 2024. Okay, I'll see you in paper 2.